Higher NAB, Unit 2, Outcome 3. This outcome's on trigonometric equations and formulae. We've got 3 questions to complete, questions 6, 7 and 8. I'm going to start with question 6. And what we're going to do here is we're going to solve the equation. Sine 2x is equal to root 3 over 2. And I can see the limit that I have here. So x is going to lie between 0 and pi. Normally we would usually work to 2 pi. This one here, we've got to be very, very conscious of the limit that's here. Right, let's go ahead and try and solve this equation. First thing that I would do is I'd be looking in here and I'd be trying to determine whether that's a positive or negative value there. Okay, it is a positive value. Okay, so what I'm going to do is I'm going to work out from my CAST table whereabouts the angles are going to lie. So if sine is positive, I know it's going to lie in the first quadrant and it will lie in the second quadrant. What I'll do first of all is I'll work out the acute angle. So my acute angle is going to be equal to, so I've got everything the way I need to do it, so straight away I'm just going to go for 2x is equal to the inverse sine of root 3 over 2. From there I know that on my table of exact values root 3 over 2 is going to work out to be in radians pi over 3. So I've got 2x is equal to pi over 3. Working in degrees, if that's the way that you like to do it, that'll be 60 degrees. I'm generally going to work through in radians here, and if you want to convert at the end, I'll show you how to do that as well. So the thing is, with the acute angle, it's going to be one of my solutions, so I'm going to start with this one here. So that's going to be my quadrant 1 solution. Okay, so I'm starting with 2x is equal to pi over 3. I'm going to write down on this line here my next solution as well. So my next solution is going to be my quadrant 2 solution, and that's going to be 2x is going to be equal to, and remember what we do is for in this quadrant here, it's going to be pi minus the angle that I worked out in this quadrant here. So that's going to be pi minus pi upon 3. Right, when I'm doing this normally, if I'm looking at a 2 pi, what I would do is I would then be considering a further option. So I'd be looking at another angle from there, and all I'm going to do is take that first one and I'm going to add on to that one full cycle, which would be 2 pi. So the way that I would be working this question out would be looking at 2 full cycles. When I work out the answers to 2 full cycles, I would then divide by 2 to bring the graph within the 0 to 2 pi, and that's the way I would normally work this. Right then, so I would have another solution coming from this one here, and that would be 2x will be equal to pi minus pi over 3, and remember I'm just going to add on another full cycle. Right, let's go and work out what x is equal to here. So I've got x is equal to pi over, so it's going to be 3 divided by the 2, so that's just going to be pi over 6. From here, what I've got is I've got 2x is going to be equal to, and if I look at working in thirds, I'm just going to change this here to thirds. So that's 3 over 3. Pi is just the same as 3 over 3. Or 1 pi is just the same as 3 over 3. So if I subtract that, I'll get 2 pi over 3. And if I divide that by 2, I should get x is equal to 2 pi all over 6. So x here is going to be equal to pi over 3, just simplified down. If I look at my next value that's here, what I'll do is I'll go for 2x is equal to pi upon 3, and what I'll do is I'm just going to change that pi here, the 2 pi, into thirds. So what that should be is, I'll just make that 6 over 3, because that's the same as the 2 pi. Then I'm just working in thirds here, so I know that 2x is equal to, gather these together, 7 pi upon 3, so x is going to be equal to divide by 2, so that's going to be 7 pi over 6. Now if I look at this here, 7 pi over 6 is greater than just pi, because if I'm dealing with sixths, pi is going to be equal to 6 over 6 pi. So this one here is out of range. This one here, if I calculate this one here will also be out of range. I'll calculate it through so that you can see that. So 2x is going to be equal to, I'm going to change this to 3 over 3 pi. I've got minus pi over 3, and I've got plus, because I'm dealing in thirds, that'll be 6 over 3 pi, because 6 over 3 is just the same as 2. If I gather these up, what I have is 3, 9, take 1 away would give me 8 pi over 3. Dividing by 2 would give me 8 pi all over 6, and then x here is going to be equal to 4 pi over 3. And as I said before, that there is out of range. So what I can see here is I have two solutions, and my solutions will be I've got x is equal to pi upon 6 and pi upon 3. And that would be my solutions there. Okay, if you work these out and you worked out your answers in degrees, what you would work out is you would have x is equal to 30 degrees for the first one. To convert that into radians, so for radians, what I would do is I'd just multiply the 30 by pi over 180. And all I would do is simplify the fraction down. So if I've got 30 there, I can divide that by 30 and get 1. Divide 180 by 30, and what I would get is 6. So that would give me pi over 6. And for this one here, what I would have is, for my second solution, would be x would be equal to 60 degrees. And from there, all I would do is just the same thing. So working in radians, all I'm going to do there is I'm going to multiply by pi over 180, divide the top by 60, that gives me 1, divide the bottom by 60 gives me 3, which gives me pi upon 3. And you must state the answer in radians here. Let me just show you what this question really is all about. So it was sine 2x is equal to root 3 over 2. I've got a diagram of the graph that would represent this question. So the graph here is y is equal to sine 2x. Okay, so I've got two cycles within 0 to 360 degrees, or in radians here it's between 0 and 2 pi. And really what I'm asking in the question is that whereabouts on the graph of y is equal to sine 2x is the value root 3 over 2. Root 3 over 2 is a value that's up here, and that's 0.866 if you work it out in your calculator. And all I'm looking for is whereabouts on the graph does that line hit the graph, the curve. And there it is there, one value at pi upon 6, another value here at pi upon 3. I've got the other values that I'd calculated up at the top here, 7 pi upon 6, and what I've got here is the 4 pi upon 3. Now remember, we were limited to this range here. So that was our maximum range, so the range we were limited to from here to here. Okay, so the only two solutions I had were these ones here. Let's have a look and see how that's marked. Right then, so what we've got here is we've got a mark for, let's see what we got. We've got one mark for getting this part right here and processing that through and getting one mark there. And the next one would be for getting this part here all the way through to there. So I've just got 2 marks in this question here. Now the kind of strange thing with this type of question, I can get my marks in this direction here, so if I get that right, that's great. If I get that one wrong, I lose 1 mark at that side, or what I can do is I can get the mark for getting these two parts right here, and then getting these two parts right here. So two different ways I can mark it. I can mark it either vertically or horizontally, and I should be looking to get 2 marks for that question. Let's move on to question number 7. Right, for question 7, we're going to write down the values of cosine x and sine y when I see the two triangles that I have that are here. Right, so the first thing I'm going to do is I'm just going to use Pythagoras theorem to work out this side here. So all I'm looking to do is, I know that this is one of the shorter sides, so what I'll do is I'll take the hypotenuse squared, subtracting one of the other shorter sides squared, and from there I should get the answer. So that's going to be 25 minus 9, and taking the square root of that should give me an answer of 4. So this side here, the value is 4. And that will help me to get the things I'm looking for cosine x and sine y. This one here, I'll just do the same. So for this side here, if I have to work out this dimension, I know it's a shorter side, and what I'll work out is the square root of, and it's going to be the hypotenuse subtracting the other side there. If I work that through, 169 minus 144, take the square root of that, and I should get an answer of 5. So this side here should be equal to 5. This side here equal to 4. Right, so now what I can do is I can write down the value of cosine x. So remember, cosine x is going to be equal to the adjacent over the hypotenuse. So the cosine of x is equal to the adjacent over the hypotenuse when we deal with SOHCAHTOA. So cosine x is just going to be equal to 4 over 5. If I'm looking at the sine of y, so sine y is going to be equal to the opposite over the hypotenuse. So opposite over hypotenuse, and so the sine y is going to be equal to 5 over 13. And usually in this type of question we just use the triangles to work out some of the things that we need to know. Okay, I can see down here that I'm going to be working out the cosine x minus y, and I'm going to have to expand that. So while I'm here, I'm just going to write up the value of sine x. So sine x is going to be equal to 3 over 5. And I'll look at cosine of y, and the cosine of y is going to be 12 over 13. And what I'll do is I'll be using these things here in part B. Okay. Right, so to show the exact value of cosine x minus y, and I have to show that it's equal to 63 over 65, what I'll do is I'll first expand this side out here. So for looking at the expansions, I would then look at the formula sheet that's on the front page of the NAB. And what I'd be looking at is that I've got a cosine x minus y. So a cosine of, if I look at that as being x minus y, and I'm going to expand it out using this formula here. The minus is on the bottom side, so that's going to change to a plus when I expand it out using the formula. So remember to use that formula sheet. Right, so here we go. Let's write down the question that we're looking at. So we're going for cosine x minus y, and I'm looking for that to be equal to 63 over 65. So let's look at the left hand side, and what I'm going to do is I'm going to expand that by using that formula. So that'll be cosine x, cosine y, remember the sign changes, and that'll be sine x, sine y. All I've done is used the formula from the formula sheet. I've worked out the values for cosine x, so cosine x is 4 over 5, so I'll just put in the fraction from there. I've got cosine y to work out. Cosine y is 12 over 13. I'm going to add to that sine x, so sine x is here, that's 3 over 5. I'm going to multiply that by sine y. Sine y is 5 over 13. Right, when I pull this together, what I'm going to do is I'm going to multiply the fractions out. So on the bottom there I can see that I've got 65 here. On the top, 4 times 12 is going to give me 48. I'm going to add on to that, 3 times 5 is 15, all over 65, and from there, if I gather them together, I've got 63 over 65, and that there equals the right hand side. And that's the question complete. Let's look at the marking scheme for this question. So let's go for the first mark I'll get is for cosine x, here, cosine x being 4 over 5. I'll then get sine y of being 5 over 13. So there's 1 and 2 marks. For the mark number 3, it's really for basically looking up the formula sheet and expanding out the cosine x minus y correctly, just by using the formula sheet. And then finally, the last mark will be for doing the work that's involved here. Okay, that's that there. So that's 4 marks for this question, 2 for part A and 2 for part B. And that's that one complete.